Today we are going to learn about Python comments. Understanding them properly will make you a better programmer. So let's break down every type of comment in Python line by line. Let's start with the most basic type, the single line comment. Here is our first example. So what's happening here? The hash symbol, also called the pound sign, tells Python to ignore everything that comes after it on that same line. Python's interpreter literally skips over this text when running your program. It's as if this line doesn't exist to Python, but it exists for us humans reading the code. Now let's see a practical example. In this case, the comment on the first line explains what the following code is about to do. The hash symbol starts the comment, and everything after it until the end of that line is the comment text. On the second line, we have actual executable code that assigns the value 10 to a variable called length. Notice how the comment and the code are on separate lines. But here is something interesting. You can also put comments at the end of a line of code. This is called an inline comment. First, Python executes the code in this line, which assigns 5 to the variable width. Then, it encounters the hash symbol. Everything after the hash, including the text measured in meters, is ignored by Python. The key thing to notice is those two spaces before the hash symbol. This is a style convention from PEP 8, Python's style guide, which recommends at least 2 spaces between code and an inline comment for readability. Let me explain the mechanism behind this. When Python reads your file, it processes it character by character. The moment it encounters a hash symbol outside of a string, it says, okay, everything from here until the new line character is a comment, and simply skips to the next line. This happens during what's called the tokenization phase, before your code even runs. Now here's where it gets interesting. Python doesn't actually have a dedicated multi-line comment syntax, like some other programming languages do. But we have 2 ways to write comments that span multiple lines. The first way is to use multiple single-line comments. Here, each line begins with its own hash symbol. So Python sees the first line, encounters the hash, and ignores the rest of that line. Then it moves to the second line, encounters another hash, and ignores that line too. And the same for the third line. We are essentially stacking single-line comments on top of each other. Now, the second way uses something called a multi-line string. Let me explain what's really going on here. Those 3 question marks create what Python calls a string literal. Normally, strings in Python use single quotes like this or double quotes like this. But when you use 3 quotes in a row, either 3 single quotes or 3 double quotes, Python allows that string to span multiple lines. Now, here's the crucial part. This isn't technically a comment. It's actually a string literal that exists in your code. However, since we are not assigning it to a variable or doing anything with it, Python creates the string and then immediately discards it. The string object gets created in memory for a brief moment and then gets garbage collected. So it behaves like a comment, but technically it's an unused string literal. This brings us to docstrings, which are a special and important use of multi-line strings. You can skip this part if you haven't learned about function. However, for the sake of initial exposure, you can continue to listen about docstring. Look at this function. Let's break this down line by line. On the first line, we define a function called calculate_area that takes 2 parameters, length and width. Then, immediately on the next line, still inside the function, we have a multi-line string enclosed in triple quotes. This is called a docstring, which is short for documentation string. Unlike the multi-line string we saw earlier that just gets discarded, a docstring is special because it's the first statement in a function, class, or module. Python actually stores this string in a special attribute called __doc__, which means it becomes part of the function's documentation. Inside this docstring, the first line gives a brief description of what the function does. Then we have a blank line. This is a convention that separates the summary from the details. Next, we have an args section that documents each parameter. The word length followed by a colon explains what the length parameters represent, and the same pattern follows for width. After another blank line, we have a returns section that explains what the function gives back. Finally, the actual function code appears on the last line, where we return the product of length and width. Notice how the docstring comes before any executable code in the function. This positioning is what makes it a docstring rather than just a random string. Here is something cool. You can actually access docstrings programmatically. On this line, we are calling the print function. Inside the parentheses, we access the calculate_area function and use dot notation to access its special __doc___ attribute. This attribute stores the docstrings we wrote earlier. When this line executes, Python will print out the entire docstring text to the console. This is how tools like help function and documentation generators can extract your documentation automatically. Comments are also used for temporarily disabling code during debugging. On the first line, we have a hash symbol followed by a print statement. Because of that hash, this print statement will not execute. It's been commented out. This is useful when you are debugging and want to temporarily disable some code without deleting it. The second line is active code with no comment symbol, so Python will execute this line normally, multiplying length by width and storing the result. The third line is another commented out print statement. Again, the hash symbol at the beginning means Python ignores this entire line. Programmers often comment out debug print statements like this once they've finished debugging rather than deleting them, because they might need them again later. Now, let's talk about writing good comments. Here's an example of a bad comment. Why is this bad? Well, the code itself already clearly shows that we are adding 1 to x. The hash symbol starts the comment, and the comment text says increment x by 1. But this is completely redundant. Anyone who knows Python can see what this line does. This comment adds no value. Here is a better approach. Now the comment explains why we are incrementing x, not what we are doing. The hash symbol begins the comment, and the text account for 0 indexing offset tells us the reason behind this operation. This adds explanation to the code that you couldn't get from just reading the code itself. And there you have it. Every type of comment in Python explained line by line. We covered single line comments with the hash symbol, multi-line approaches using multiple hashes or triple quoted strings, docstrings for documentation, and inline comments. Remember, good comments explain the why, not the what. Your code should be clear enough that the what is obvious. Use comments to add context, explain decisions, and document your functions with docstrings. Thanks for watching. If this helped you understand Python comments better, please like and subscribe. Drop a comment below if you have questions, and I'll see you in the next video.